To query the database from our application, we need to pass a secret key along with our queries. So from our FaunaDB dashboard, go to Security and click New Key. Make sure to choose the right database you like to access with this key and click Save. Then make sure to copy your secret key as you won't see it again. And if you don't have it, you will need to create another key. Next, go back to your editor and open the .env.local file. Create a new environment variable named Next public FaunaDB secret and paste your key. Note that we added the next public prefix to our variable name to be able to access it anywhere in our code. By default, without this prefix, the environment variables are only available in the Next.js environment, meaning they won't be exposed to the browser. Next, open your terminal and install the FaunaDB JavaScript driver using npm, along with the Slugify and the UUID packages that we'll use to create unique slug for our blog posts. Now go back to your editor and create a new file inside the lib folder and name it fauna.js. This is where we are going to instantiate our Fauna client and create all of our queries. So start by importing Slugify, UUID v4 from UUID, then FaunaDB, and the query module that contains all the function to create Fauna query expressions. Next, create a class named Query Manager. We'll start with the constructor. Inside it, you can instantiate a FaunaDB client by passing your secret key from the environment variable we have created earlier. And that's it for the constructor. Let's move on with the queries. Create a method named createPost with an object as an argument that contains the title, the content, and the author of the blog post we want to create. Then, we can issue a query to create the blog post using our FaunaDB client instance, and construct the actual query using FQL. Call the create function from the query module, and specify the collection we are targeting using the collection function. Then, pass the blog post detail as a data object. When creating a post, we set the publish property to false to create a draft of our blog posts instead of publishing it right away. In other words, the user will have to take action later on to actually publish its blog post. We'll create another query later for publishing a post. Then, we set the creation date to now using the now function and the toString function from the query module to cast the date time into a string. And we do the same thing with the updated date time. The next query is for fetching a single blog post using its ID or document's reference in FaunaDB language. As we have seen before, this type of query is pretty straightforward. We use the get, the ref, and the collection functions along with the post ID to return the corresponding document and its data. Let's create a similar query to fetch a specific blog post using its slug. So instead of using the ref function, we need to use the match and index functions from the query module and pass our post search by slug index we have created earlier, along with the slug value. As you can see, once we have created an index, it becomes really easy to issue queries to search for documents. For our next query, let's fetch multiple blog posts at once. So let's call our function getPosts and accept an option object as an argument. Then use the map and paginate function to fetch several documents at once using our post search by publish index with true, so we only get the published blog posts. Let's actually use the join function so we can combine our index query with another one to sort the result by the publish at field in descending order. So let's recap what we have here. The join function finds all the documents from the first index where the published field is equal to true, and join the result with the second index to sort it by the publishing date in descending order. To use our two indexes with the join function this way, we actually need to refactor a bit our second index. So go back to your FaunaDB dashboard and open the settings of the post search by publish at desk index. To join our two indexes, we need to update the terms of this index and include the reference field as it is the field returned by the first index. As you can see, we are not able to edit our index terms once the index has been created. So we need to delete it and recreate it again from scratch. Also delete the post sort by edited at desk index as we will run into the same issue later. Next, go to the Fauna shell and create the two indexes again by specifying the ref field in the terms. Then check that both indexes have been created properly. As you can see now, it contains the ref field as a search term. Alright, now go back to your editor as we will finish constructing our query. So add the option parameter to the paginate function. This option can be used to pass the maximum number of documents to return in a single page. By default, the page size is 64. We'll also use this option object later to pass a cursor to retrieve the next pages. Finally, we have the lambda function to actually return all the documents data and not only the references. Okay, next copy-paste our getPost function below and change the name to getDraft. We'll use this new method to fetch the posts that have not been published yet. The query is quite similar as the one we just built. The only thing that we should change is the boolean we pass to the first index. Replace true with false as this time we want the unpublished blog posts. Then also change the second index name. As we don't have a published date time, we are going to sort by the updated date time and update the lambda function accordingly. Now let's create a method to update a blog post. We can do so by using the update function from the query module and passing the reference of the document we want to update. So we can use the ref and the collection function and pass the document's ID. Next, we pass the new data from the parameters, destructure it using the spread operator, and update the updated date time. Now let's move on with the delete post method. To delete a document, we simply use the delete function and pass the reference of the document we want to delete. That's all. This one is pretty simple. The last method we need to implement is the one to publish an existing blog post. So first, get the reference of the document we want to publish. Then retrieve it using the get method. Note that all the methods from our FaunaDB instance return ES6 promises. So as I'm using the await keyword inside my function, I need to add the async keyword to it. Then, once we have retrieved the blog post, we can check if it already has a slug value. If not, we construct it with the slugify function and the blog post title. We convert it to lowercase and remove any special character with the strict parameter. Then, for the slug to be unique, we need to append a unique identifier at the end using UUID. So now that we have our slug, let's issue an update query using the update function with the document reference, the data, and the slug. Set the publish field to true, and update the publishing date and the updated date time as well. That's all for our queries. Actually, there is one more thing we need to do to easily use the data from the query results in our application. By default, the FaunaDB queries will return a few other fields along with the document's data itself. So I have implemented a basic recursive function to flatten the query result. This function is taking the result as an argument and return the data by spreading the data field from the result and adding the document ID from the ref field, so that we have everything we need inside the same object. This flatten data function also works if we have a result with multiple documents stored in an array, by calling itself recursively and flattening every document inside that array. Alright, so let's use this function with our queries below. Finally, create an instance of your query manager and export it from this file.